All right, so this is the last lesson in the scale factor unit. Um, really the only difference here is we're just talking about triangles specifically. Okay, so um, the math though really isn't any different. So quick review of triangles you've learned in some previous courses, but we haven't talked about it this year, is that the sum of all interiors of a triangle adds up to 180. Okay, what does that mean? It means it doesn't matter what kind of triangle you have. Could be a right angle triangle, could be an obtuse triangle, okay, could be an acute equilateral triangle. If you take the three angles that make up the inside of a triangle, 1, 2, 3, or these three here, or these three here, those will all add up to 180 degrees. Okay, in this case, let's say this one looks like it's a right angle, that's 90 degrees. This one looks like it's about 45 degrees, and this one's about 45 degrees. These three numbers added together will add up to 180. Doesn't matter what triangle it is, the three angles on the inside of a triangle always add up to 180 degrees. Now, that'll become important in just a minute. This is just a quick lesson or refresher on how to label a triangle. Okay, so when we're labeling a triangle, you label the edges, or sorry, the vertices, which is like the angles. Okay, so you're like where they come to a point here. We're going to label the angles with a capital letter. Okay, so I'm just going to call this one like A and B and C, and we're always labeling those with capital letters. When we label the sides, so if I want to label this side here, the way that I do that is first off, I'm going to use a lowercase letter. The sides use lowercase, and then I use the letter that is right across from it. So this A here is like this angle A is directly across from this side here. It's not like it's next to this one, it's next to this one, but it is right directly across from this one. It's not touching it. So I label this one a lowercase a. So it's the same letter, but the angle is uppercase, the side is lowercase. Okay, and then you just do the same thing for B and C. So for angle C, its matching side is the one that's right across from it, and we do a lowercase c for that one. Keep it in red here for consistency. And then this angle B right across from that one is side B, which we do lowercase b. Okay, so this is the standard way that people label triangles, is with angles having capital letters, and then the sides are lowercase letters that match the one across from them. So then down here is an example that says, given the toe, which is supposed to be 2, okay, given the two triangles below, find the length of n. Okay, so length of n is lowercase n. Let's talking about this lowercase n side here. Let's find that side. So now it did not say up here that these two triangles are similar. Okay, normally these questions will tell us that these two triangles are similar, the two shapes are similar, whatever, which means that we can use a scale factor to find out the different lengths between them. Okay, this time it didn't say that. Now, the way that we can figure out are these two similar is that similar shapes will have all the same angles, and then their sides will be proportional, meaning they're all being multiplied by the same number, right? All the sides are getting twice as big, or half as big, or 5 times as big, whatever. With triangles, if all three sides match, if all three angles are the same, then the sides will also, those will all be proportional. So you know that two triangles are similar if they have all the same angles. In this example, it has told us this angle here, they called x, and this one they called x. Okay, that means that these two angles are going to be the same. These two are definitely the exact same. This one here, normally they would label it with like a little tick or something here to show that these two are the same, but these two angles are also the same. Okay, I would, in any other question, on any kind of test, I would always put a tick there to show that these are the same, but these two angles are also the same. So that's another match of angles. But it doesn't tell us anything about this one here. Let's label this one with like 2 ticks. Okay, we don't know is this angle and this angle the same. But we know that all three angles together are going to add up to 180. So like this one plus this one plus this one are going to add up to 180. And we know that this one plus this one plus this one are going to add up to 80. So we know that these ones match. So I'm just going to make up a number here to put in here just for an example. Okay, let's say that this one was like 60 degrees. Call that one 60. We know that then that this one is 60 degrees as well. And we know that these two are the same, and this looks like, maybe I'll call that one 70. Okay, let's just say that this one was 70. Normally you won't do this. This is for the sake of an example. So if this one's 70 degrees, we know that this angle also has to be 70 degrees over here. Now this angle we don't know anything about, but what we do know is that these three angles together have to add up to 180 degrees. So 60 plus 70 plus this has to add to 180. Say like 60 plus 70 plus something is going to equal 180. So this together makes 130, and so we need 50 more in order to get to 180. So this angle would have to be 50 degrees. Okay. In this triangle, it has to be the same. 60 plus 70 plus something has to give us 180. Because these are the exact same numbers, it's going to be the exact same answer. 60 plus 70 plus 50 is going to give us the add up to 180. So why I showed you, like why I made up some numbers here, was that it doesn't matter what the numbers are here. If these two are the same, then that third angle is going to be the same, because if these are the same, we know that this one has to add up to 180, and this one also has to add up to 180. So no matter what these two are, that third angle is going to be a match. So this is all just a really long way of saying that if you see that there's two pairs of matching angles in a triangle, the third one is also a match. And as soon as all the angles are a match, that means they are similar. Okay, it means that you can use a scale factor, say that all the sides here are going to be like twice as big or half as big or whatever to get to this one. Okay, so that was all just a long-winded way of us saying that these two triangles we now know are similar. Okay. Now that we know that, we can find out the scale factor. So I'm just going to erase this stuff here so it gets a little bit less confusing. And remember that our original goal was to find that side n. So the first thing we're going to do is we're going to find the scale factor. Scale factor is the new side divided by the original side. I'm going to call this one my new and this one my original. And I need to pick a pair of sides. So this 2 and this 5. So it'll be scale factor is 2 divided by 5, new divided by original, which is equal to 0.4. Okay, so my scale factor is 0.4. So I'm just going to take this side here and multiply it by my scale factor times 0.4 to get my new side over here. So 7 times 0.4 will give me this one. This one ends up being 2.8 inches was our unit there. So, and that's it. Okay, this question is done. So had this question just said they were similar, we wouldn't have had to worry about are these angles the same, all that kind of, it just would have been the exact same as before. Find the scale factor, multiply by it to find our new one. Now, this page, I don't like this example. I don't like that it's difficult to kind of tell what triangles, what sides are the same, and so we're going to skip that one. But for this one, okay, this one tells us that in these two, in the diagram below, that the triangles are similar. Okay, this one tells us right off the bat, okay, that those three angles are going to match these three angles, so we don't have to worry about finding that out. Find the length of the sides labeled X and C. Okay, we're only going to do the one that's labeled X. We're going to find this one. So how are we going to do that? We're going to find the scale factor, and because we're looking for this one, it's kind of easier if we call this one our new and this one our original. We could go the other way as well, as long as we're being consistent, but I'm just going to call this one my new, this one my original. So I'm first going to find the scale factor. Scale factor is the new side divided by the original side. So I need to find a pair of sides. So this one and this one, 18.8 feet and 8.2 feet. 18.8 feet divided by 8.2 feet, that's my new divided by my original, to get my scale factor. Once I have that, I'm just going to take 12.7 and times it by the scale factor to get my answer. All right, so if you put 18.8 divided by 8.2 in your calculator, you will get 2.29. Okay, that is your scale factor. So what that's saying is that this triangle, or if we take this triangle and multiply by 2.29, we will get this triangle. Okay, this triangle is 2.29 times bigger. So to find this missing side, I just took this side here, times it by our scale factor of 2.29, and got 29.1 feet is this side here. And that's it for that one. Okay, and here's our last example. So anytime you get to kind of confusing-ish word problem like this, you're going to want to draw a picture. Okay, so this one says that Ravi notices a 2-meter pole casts a shadow of 5 meters, and a second pole casts a shadow of 9.4 meters. How tall is the second pole? Okay, so um, let's draw a picture of the first one. So there's a 2-meter pole sticking out of the ground. That's 2 meters, and it casts a shadow of 5 meters. Okay, so I'm going to then draw. This is like his shadow. Okay, we're making a triangle out of this. And then there's a second pole that casts a larger shadow. Okay, so I'm going to draw then a larger pole that is casting a larger shadow of 9.4 meters. There's the shadow being cast down. Okay. And it says, how tall is the second pole? I'm just going to label this one here with an X. Say like this is what we're looking for. So how tall is the second pole? How do we find that? Well, the key is that these are making similar triangles. How do we know that? Okay, if all the angles are the same, then we're going to have similar triangles. Well, a pole coming right out of the ground is going to be a 90-degree angle. Okay, if something coming straight out of the ground, that's 90 degrees. And then this angle here is like the angle that the sun is casting the shadow down. Okay, so like, let's say there's the sun, okay, and it's casting its rays down here, and it makes an angle here. Okay, in this diagram, you know, like the sun's really close, but in real life, the sun is so far away that this is going to cast the shadow down here. That light is going to be coming down at the exact same angle. Okay, so in real life, sunlight coming down from way up in the sky, all those light beams are going to be coming down at the exact same angle. And so that just means that the shadows being cast has the same angle here. So I'm just going to label that with a little tick there. These two are the same. We said earlier that if you know that two of these angles are the same, that third angle is also going to be the same, right? Because all three of these angles have to add up to 180. So like this plus this has to add up to 180. So these ones are also going to be the same. I'm just going to label that one with 2 ticks. Okay, so this has told us that we have similar triangles. All these are the same angle, so we can use our scale factor here. That will work. So we'd say our scale factor is equal to our new divided by our original. In this case, I'm going to call our smaller pole here the original, and the new is the bigger one that we are looking for the height. So I pick a pair of sides here. I'm going to use 9.4 and 5. Those ones are like both talking about the length of the shadow. And I'll say 9.4 is my new divided by 5 is my original. And I'm kind of showing it a slightly different notation here. This is still accurate. Before I was kind of going down, I was saying scale factor is equal to 9.4 or 5. Okay, this way I'm just kind of showing my work sideways. Both are correct in this case. So 9.4 divided by 5 will give me my scale factor, and then I'm just going to take that and multiply 2 times my scale factor to get my number there. All right, so if you put that into your calculator, you get 1.88 as your scale factor. And then to find our missing side here, you take this, the height of the original pole, and we're multiplying it by our scale factor. So 2 meters times our scale factor of 1.88 gives us our new height of 3.76. And yeah, I mean, this is actually like, this does work in real life, by the way. You'll see like there's no like weird scenario here. It's just 2 shadows of 2 different poles. So this, you know, dazzle your friends. So the, I'm not going to do these next 2 questions, but I did just want to kind of quickly show a diagram to kind of get you in the right mindset for how to answer this one. This one is a bit confusing if you can't quite picture it. So it says, assuming the slope of a hill is constant, and that a point 100 meters along the surface of the hill is 4.2 meters higher than the starting point. Because this is saying there's like some hill. Okay, there's some big hill. And we're going to say, imagine it's perfectly straight line. Okay, they're saying when it says the slope of the hill is constant, that means it's like the slope is not changing. It's perfectly straight as it's going up. It says that if you go 100 meters up the hill, let's say this, say like this is 100 meters going from here to here, that you have gone 4.2 meters high. Okay, so like you've got 100 meters along it, but you're 4.2 meters higher than where you started. Okay, you'll notice it's kind of making a triangle here. Then it says, how high will you be if you walk 250 meters along the slope of the hill? So how much higher would you be from where you started if you walk not just 100 meters, but all the way up to, this is 250. Okay, I'm going to say that, actually maybe I'll do this in red, make it a little bit more clear. From here to here is 250. Okay, and it's saying how much higher will you be? So that's going to be this height from where you started to where you are, and I'm going to label that with an X. So again, what we have here is we have two similar triangles. Our first triangle was this one that we drew here. We have a right angle here, and we have this angle here, and we don't know what that one is yet. So that was 100, what's this side, and 4.2 is this side. We made a second triangle by continuing to go up this hill from here to here, and now we want to know what's the height of that, and it's here. So this second triangle also has a right angle, just like our first one, so that matches. And it uses the same angle here, so it has two angles the same, and so that third angle is also going to be a match. So this angle is the same for both of them. They both have a 90 degree, and so then this angle here is going to have to match as well, because they are all going to have 20. So that means we have two similar triangles. We can use our scale factor. Okay, so that's the setup for that one. Lastly here, I just haven't used the term legs for triangle before. It's saying someone's sewing a patchwork quilt, and here's their ratio. The design consists of right angles that have legs that are 2.2 centimeters and 4.6 centimeters long. So that's just triangles that one side's 2.2 and the other's 4.6. So that should be enough to get you through this assignment. It's more the same, but again, draw pictures. It really helps. Good luck.